All right, so good morning. Thanks everyone for coming. This is our 18th annual UCLA Discover Bioengineering event. I'm Dan Kamei, and I appreciate you all attending today. It's also our second annual virtual IB Discover event, so welcome to the Matrix as well. The agenda today, from 10 to 10:20, we have our faculty speaking. From 10:20 to 10:35, we have the executive board of our student society speaking. And then from 10:35 to 10:45, we're gonna play a game. We didn't do this last year, so we'll see how it goes, but you gotta pay attention if you wanna win. And the prize would be a shirt, like a UCLA Bioengineering shirt. So, you gotta pay attention. Then we'll do Q&A. It'll be with the faculty and the student executive board for BMES. And then from 11 to 11:15, we have our alumni speaking, and then 11:15 to 11:30, question and answers with alumni. And then 11:30 a.m. to noon, we'll have breakout sessions. And they're based on your last names, and all the links should be already on the School of Engineering site. Please go, because we have 7 faculty each in one of the 7 rooms. We have 5 alumni here. We have students helping. So I appreciate it if you could at least go to the breakout session, even if you're just going to ask one question. Okay, so without taking more time, I'd like to introduce our chair, Professor Samueli, who's going to give an overview about the department.
Thank you very much, Dan. Next slide. Good morning, everyone. So today we hope to provide more information about engineering program to help you make decisions. So I know many of you have made decision to come to UCLA, or and some of you are still thinking. So why UCLA? UCLA is one of the top research institutions in the world. And we have so many excellent research programs and education programs on the same campus. So many of these are top 10 or top 20. Really, this offers many opportunities for you to develop your interest area and even change majors if you want to. And for those who are interested in medical school, for example, pre-med program, you have a lot of opportunities to do shadowing in the hospitals and work with doctors. And for bioengineering, we have many unique features. Next slide. The goal in bioengineering is to perform cutting-edge research, train the next generation of leaders at the interface of engineering and medicine, and also promote the collaborations in different disciplines at UCLA. We have a very unique opportunities at UCLA. You can see from the faculty in bioengineering, we have a core faculty. Now we have actually 14 core faculty now in different areas. And we're going to tell you more information in the next slide. In addition, the department is supported by, can we go back? In addition, the department is supported by many joint faculty in various departments and programs on campus, in medical school, engineering, dentistry, letters in science, in industry. And we have very unique opportunity at UCLA. And here we have top engineering in medical schools on the same campus, basically across the street. And we have so many opportunities for students to do research. For example, based on the statistics, our undergrads have at least 1 year research experience for 90% of our students. And many of them have even 2 years experiences in research labs. Next, please. The research and education programs in our department focus on 4 major areas. The first is molecular, cellular, and tissue engineering. And this is a very broad area that includes stem cell therapies, biomaterials, drug delivery, etc. And the second area is kind of interface with other engineering disciplines in medicine. It's biomedical imaging. And this could be from a molecular level to cellular level or even a whole human system level. The third area is biomedical devices and instrumentation. You can see some examples here. It could be a portable and wearable devices or even large instruments that are being used in the hospitals. And the fourth area is an emerging area in the past decade. It's growing very fast. Biomedical data sciences that includes bioinformatics, precision medicine, artificial intelligence, machine learning, and many new emerging areas that could have broad applications in bioengineering, in medical applications. Next, please. The quality of our students really are the very top. You can see from this table, the job market actually in bioengineering is growing very quickly, especially in California. You all know California is one of the major hubs in biotechnology in the country. And from in the past 10 years, you can see the application numbers almost doubled. And if you look at the very last row, you look at the unweighted GPA, it's the best, I think, in all disciplines, probably in UC system, even in all Ivy schools. So it's almost perfect. But there are many other aspects for us to measure the success of our students. Anyway, it's the best of the best. Next. We're going to have more information on our curriculum later. And I think our vice chair and undergrad affairs and also students will give more information. In general, our curriculum is very broad and we're trying to integrate all aspects in engineering, medicine, and physical sciences. In addition, we also have depths in certain areas. The students will have many opportunities to learn from design competitions, labs, and research opportunities at all levels. Our mission is really to train the next generation of leaders who can work effectively at the interface of engineering and medicine. Next slide. So we have a community, and you have opportunity to interact with other students, do networking, and form study groups. You also work together on different kind of projects in class. Also in the biomedical engineering society. And we have annual meetings between faculty and advisees. We could have one-on-one interactions with faculty, peers, and other students. Next. And today we have several faculty who will participate in the panels. They also give you more information in the presentations. You are going to have opportunity to talk to them either in a group setting or individually. Next. And Urki, who is the academic counselor, is here today. And also we have alumni advisor, Dr. William Gooden, who may join us later. With that, I want to introduce Professor Jacob Schmidt. Professor Schmidt is our undergrad vice chair. He will give you more information on our curriculum. Thank you.
Thanks, An. So, among different bioengineering departments in universities around the country, there are a number of common elements. So rather than take you through every single class in our curriculum, I'm going to tell you about the classes that we offer that make our department and our program unique. I'll start out with BE 167L, which is a class that's offered in the sophomore year. This is a laboratory, gives students hands-on experience with really divergent fields of bioengineering. Song mentioned that bioengineering is a pretty broad major, and it really is. You have some areas that are very biological, tissue engineering, cell culture, and so on, and some other ones that are, electrical associated, mechanical associated with devices, and so on. And so if you're a student and you're interested in a lot of different subfields, or you don't know it all, 167L will help you figure out what kind of bioengineering interests you. Not only that, but the fact that we offer this hands-on lab in your sophomore year, it will give you laboratory practical experience that will encourage you and assist you in achieving a research position later on in the department. And that's a big area of emphasis for us. And I'll talk a little bit more about that later. Next slide. So as far as that research goes, a big thing for us in this department makes us unique in the School of Engineering at UCLA and maybe in other departments across the country is that you can do research projects and have them count towards your graduation. So we really encourage research. And so we don't want students that are devoting a large amount of time doing research to suffer in their other classes. So we allow students to take 2 of these BE 199 classes to count towards their graduation. And so students, if you take 167L in your sophomore year, you've got a couple of years where you're able to do research projects. And students that are highly productive in these research labs, you're actually able to author peer-reviewed research publications with faculty. And that is just such a great leg up if you want to go to med school, if you want to go to grad school, or even if you just want to get a job straight out of graduation. It's just such a huge advantage. Next, please. So, as evidence of this research, let's just look at the second bullet point. Getting 10 out of 14 engineering outstanding bachelor students, just statistically, this is impossible. We've got 7 departments in the engineering school, so our fair share here is 2. And not only that, but our department's small compared to some of these other departments. So we definitely get more than our fair share of these outstanding bachelor student awards. And, for sure, every one of the students that's won this award, they've been doing research and really just taking their undergraduate education to the next level. So the research has really, it helped out a lot of students. And like I said, whatever your post-graduation plans are, maybe you don't even know what they're gonna be. And maybe you shouldn't know if you're a high school senior right now. The research will definitely help you achieve a bunch of different goals. Next, please. So if you're going to medical school, our core curriculum is enough for you to achieve your requirements for med school, except for one class, which is LS 23L. And so that's a 2-unit class that you can easily fit. Not only that, but I think in the next slide, I'll end up talking about the technical breadth areas. And so you can choose pre-med to be your technical breadth area. And that means that you can achieve all of your med school curricular requirements without really taking any extra classes. So totally no problem. And then part of that pre-med tech breadth, you can do this biostats course. So if you're interested in medical school, that's completely compatible with our curriculum. Next, please. Yeah, so speaking of that tech breadth requirement, so we have, of course, you have to take your GE courses, general education courses, electives, and stuff like that. And you have to take your bioengineering core courses. School of Engineering also has this thing called the technical breadth requirement, which is basically trying to broaden you in a technical way. So you're required to take 3 courses outside of bioengineering. They can be in EE, they can be in computer science. You might even be able to make something yourself, like in biology or in medicine or something like that. But it's a technical breadth, so it broadens you, but in a technical way. So and that's another way for you to sort of customize your undergraduate curriculum to really sort of nail your interests. Next, please. So within bioengineering, we have these 3 tracks, and the tracks are just sort of loose guides for you to help choose what electives that you should take. So if you know that you really like devices, we've got a set of suggested classes that that you can take, or if you like biomaterials and regenerative medicine, we've got a set of classes. And then of course, if you are just sort of like interested in everything, you can take like a basic track. And so that doesn't require the specialization. So, you know, we've got these guides for you to try to match your interests. Our department is also ABET accredited. We passed a couple of years ago for the second time. And so, you know, everything's completely approved and normal. Next, please. So yeah, our capstone design, this is like the big culmination. Students, this is a two-quarter class in senior year. Students work on problems that are proposed by people that work in industry, professionals, other faculty on campus. These are problems that they have that they would like to see solved or investigated. The project that the students have worked on, we've had students that have taken their capstone project and received national awards as a result. A lot of students choose to continue their capstone project and sort of finish it off. And they've actually published papers based on these capstone projects. So it's pretty incredible. The pictures that we have here in the slide, the picture on the left is a student that made a group of students that made a automated robotic pipetter, and it's just completely hacked. You can see that there's just a manual 8-channel pipetter there, but they've hacked the electronics. They've programmed the whole thing. It's controlled by it's either an Arduino or a Raspberry Pi, and it's completely automated to do plate after plate. We've got a project here on the right where students are engineering a microfluidic device to do automated cell sorting and cell characterization. This year we had an awesome project where students were working with mealworms to try to digest styrofoam and polystyrene. So a bunch of really diverse projects, and it's just really incredible work that the students do. Next, please. So so next, Professor Aaron Meyer will talk to you about his experiences. Aaron's probably one of our first success stories. He was a graduate of the program, one of the first graduates, did his PhD at MIT, and now he's back here as a faculty. So we're very proud of Aaron. He's definitely had a great start to his career already, and he'll tell you a little bit more about his experience.
Yeah, so I just in a couple minutes thought I'd emphasize a few points because I was sitting in your shoes about 16 years ago. And I was trying to, like, I think many of you are in the position of choose between different programs. So for me, I was thinking about UCSD, Berkeley, Hopkins, or UCLA. And I think, you know, the visit was really helpful for getting a really great feel for the department. And I know that's something that's a little bit difficult to do in a virtual format. You know, what really drew me to UCLA initially was that it was strong in a lot of different areas. I wasn't completely sure what bioengineering was, and I wanted to keep my options open. But I was also really nervous about UCLA. So I came from a high school class of less than 100 people. And so I was worried that I was going to be a bit of a number in the crowd in these giant classes and not necessarily have a lot of interaction with faculty. And nothing could be further from the truth. So, you know, when I showed up for summer orientation, I met some of the other bioengineers, and I think something that's really special about bioengineering is that it's a small department that almost feels like its own little small school in this giant university with lots of resources. So by the time I graduated, you know, I think I knew every one of the faculty in the department, and I feel like they all knew who I was. I knew the staff in the department and who to go to for help when any sort of issues came up. I ended up doing research not only with faculty in the department, but working alongside some of my classmates. So, you know, by the time I got to the end of my time at UCLA, I felt like I was really prepared for grad school. And a lot of my classmates went off to, you know, medical school, grad school, went into industry, and even there's creative things that people use bioengineering for. In grad school, I felt kind of unfairly prepared. Like it's not something I'd bring up at the time, but certain classes like transport at MIT are known to be very challenging. And I felt like I was completely prepared for that. And the research experience also helped a lot, because it's really gives you a feel for what graduate school or other graduate training is like. And then lastly, I think in part because the department is this small community inside of the giant university, a lot of us have kept in touch. So we're not in school anymore. We're now, doctors working at biotech companies, working at VCs that fund biotech companies, or postdoctoral fellows. And it's really incredible to see where your classmates go. And it also kind of forms a lifelong network that you can take advantage of and to rely on through the rest of your life. So, just like we've pointed out in a few places, the program is a little unique in some of the curricular aspects. I think that's really important, but also being able to have this small community inside of, at the same time of having all these resources available is really special.
Great, thanks all of the faculty for your comments. And now we'll have the executive board of BMES or Student Society give a presentation.
Hello, thank you, Dr. Kamei. Let me share screen real fast. All right, cool. Well, welcome everyone. We're so excited to have you here. And so there's 4 of us. We are from the executive board of the Biomedical Engineering Society. And today we're here to kind of share with you guys what our club does and hopefully provide you with valuable resources if you choose to come here for undergrad. So before we hop into what the club is about, a quick introduction about all of us. Hello, everyone. My name is Lynette. I was the president of BMES this past academic year. I am a 4th year bioengineering, and as Dr. Lee and Dr. Schmidt mentioned earlier about tech breath, I am a technology management tech breath, and we can talk about that a little later. I'm also a professional writing minor and an undergraduate researcher in a computational modeling lab, actually in Dr. Meyer's lab, so shout out there. In previous years, I was involved in Spoon University and Taiwanese Culture Night, and after graduation, I look forward to working as a platform advisory analyst with Accenture. And with that, I will pass it to Tamira.
Hello, everyone. My name is Tamira Skandakumar. I am the External Vice President for the current year. I'm also a 4th year bioengineering major, and I'm also part of an undergraduate research lab, but my lab is more in the nano and biotechnology lab under Dr. Oskin. And I'm also pretty involved in engineering and non-engineering clubs. So I am an engineering ambassador. If you've taken a tour with UCLA, you might have seen me there. And I'm also director of a South Asian dance team known as Rooted Dance Company. And as Dr. Schmidt mentioned earlier, my tech breadth is in electrical engineering. So I will be moving on to be an electrical engineer full-time next year at Medtronic. And with that, I'll be passing it off to Mylon.
All right. Hi, I'm Mylon. I was the internal vice president for this past year. I'm also a 4th year bioengineering major. I joined a biomaterials neuroengineering lab. In my freshman year, we worked on spinal cord injury and brain cancer research. Also did some clinical researching and shadowing on the side at the Reagan Medical Center, which is really close by. And most importantly, I am a IM Sports 2-time runner-up. Didn't make it to a championship, but hopefully maybe another year. And I'll be headed to USC next year, and you can probably guess, but my tech breath was in pre-med, so I can answer any questions about that. I'll pass it on to Shika now.
Hello, my name is Shika. I was the technical vice president for this past school year. I'm a 4th year computer science major, actually. I was also a former Engineering 96 instructor, which is a series of hands-on engineering classes where we teach students how to build really hands-on things that encompass all kinds of engineering. So I taught the electrocardiogram class. I'm also an engineering ambassador. If you took tours or had Q&A sessions, you might have seen me there. I'm also active in other computer science clubs, honor societies, as well as organizations outside of engineering, such as IM Sports in beach volleyball. And after graduation, I'm an incoming graduate student at UCLA in the computer science master's department. So I look forward to that.
Awesome. So hopping right in, you might be wondering, what is BMES? Well, We are a professional organization geared at supporting bioengineers or anyone interested in bioengineering at UCLA. We are a big family of very passionate and caring individuals, and we're here to support each other throughout your entire UCLA experience. So if you come join the family, you're automatically in. We'll welcome you with open arms. A lot of our events bring together undergraduates, graduate students, faculty, and staff within the department for collaboration on a lot of different events. So you get to meet a lot of different people within the department and kind of network that way. And we are a nationally recognized and award-winning student chapter. Ever since all 4 of us were first years, I think our chapter has won an award every year, which is super exciting. And we hope to continue that trend this year. So BMES, what we do in a nutshell, or because we're all bioengineers in a petri dish, haha. If we treat students as the cells in the middle, we want to treat or feed these cells with different growth factors so you can flourish during your time here at UCLA. And to do that, we have a bunch of these different events surrounding professional development, academic development, technical projects, mentorship, socials, as well as community outreach, which we will talk each about a little bit more in a bit.
Alrighty, so like Lynette mentioned, we do have a bunch of different branches. One of the first branches we do have is the industry branch. So the goal of our industry branch is to bring a wide range of companies that represent the variety of futures open to bioengineering students, from medical devices to pharmaceuticals and consulting. So during the many events that BMES hosts, we connect our students to recruiters to help them get the connections that they need in order to find internships and full-time jobs in the future. Next slide, please. So our primary goal as an organization is to both prepare and provide our students with opportunities to succeed in a professional setting. So we provide resources to learn and get questions answered about industry. We also provide opportunities to understand the recruitment process, as well as ways to prepare for interviews and career fairs. And then we also provide one-on-one contact and connections with biotech companies and industry professionals. Next slide, please. So while we may have been virtual this year, we were still able to transition most of our events to an online setting. And so this fall, we held our Bioengineering Career Week, which consisted of a career fair prep such as resume, LinkedIn, and interview workshops that led to our final biotech career fair, which featured over 10 really big companies, including Medtronic, Abbott, and Roche. And then in the winter, we held panels that taught students about the possible career paths that are open to all the bioengineers, and hosted company info sessions, which we will continue to host in the spring, which include companies such as Pfizer, Moderna, and Envoy. And then oh, yes, please, next slide. Next slide. So similar to our industry branch, we also have resources that prepare students for an academic extension. So that makes sure that students are able to get the resources that they need to succeed during their 4 years at UCLA. So as current bioengineering students, we have firsthand experience the challenges that students do face during their time at college, which is why we make sure to foster a community that is supportive and provide students with as much help as we can provide. Next slide, please. So our academic branch provides a strong alumni mentorship program, which prepares students with an alum that has similar interests to you so that you receive the most applicable advice tailored to you and your needs. So we also host programs that cover various academic aspects. We hold an alumni, graduate, and medical school panel that allows students to explore academic paths that are available after their 4 years at UCLA. And during these programs, you can either hear from alumni that have spent some time in the real world, you can get advice on applying to master's and PhD programs, and also medical school programs. We also give students access to graduate school info sessions where they have the ability to network with recruiters from a university with a bioengineering related program. And for additional resources, BMES hosts an undergraduate research mixer where you can get recruited by on-campus labs. And BMES also hosts quarterly class planning workshops where you can talk to upperclassmen and receive relevant class advice about how to plan out your 4 years, and also assistance to get additional supplies that you may need to help get through your 4 years, such as lab coats. Next slide, please.
All right, so our technical projects branch is one of the newest and fastest growing of BMES. We have 4 main programs, starting with the build team, where our year-long project is a pulse oximeter. And this is a foundational team where students will learn how to build a pulse oximeter from start to finish, as well as all of the foundational engineering skills related to that, including circuitry, coding, and the biology behind it. In addition to that, we have cell team, which is similar to build team in that it is foundational, but it is mostly for wet lab skills. So this is where students will learn about cell culturing and other skills that they would need to go into a research lab in the future. After this, we have our design team, which is more advanced. This houses more cross-functional projects and are more cross-functional within engineering, as well as the skills that you utilize. Along with all of these teams, we host workshops throughout the year to expand technical skills for anyone who wants to participate in them. So like I said, we have 4 main programs, and now we're going to go into a little bit of detail about each of these. As I mentioned, Cell and Build Team are for foundational skills, whereas Design Team is for advanced. Cell Team is more geared towards research, whereas the rest are more industry driven. And then our teams are year-long programs, whereas our workshops are more one-time events. And ultimately, our goals are for students to have marketable tools and technology that they feel comfortable talking about, as well as using in the future. It's both a combination of engineering and non-engineering skills. So aspects such as circuitry and coding are often in conjunction with skills like presenting, as well as working with a group. And ultimately, we want students to have fun and set themselves up for success in the future. So as a breakdown of the numbers over the past year, we have 95 students across our 3 teams this year, which is huge compared to any other year, even though it was virtual this year. We have 10 incredible instructors who spend lots of time trying to get these students to learn and grow over the course of these years. And this year, we are very excited to announce our first ever biomedical hackathon called Biohack. So for those who don't know, Biohack, or a hackathon, is a design sprint-like event. It will happen in mid-April. And because of the online nature of the school year, it will be virtual as well. And the reason why we want to call it a biomedical hackathon is because the design aspect is geared towards solving biomedically focused problems. So teams of 3 to 6 people, students, will collaborate to solve problems. We have 3 distinct prompts for them to choose from. And the goal for them is to build, ideate, and brainstorm creative and innovative solutions to these problems. And ultimately, we want people to grow, learn new skills, meet new people, as well as network, and win some cool prizes. If you are interested in learning more, you can visit our website. It is bmes.cs.ucla.edu/biohack, and that has all the details for the event.
All right, so a big part of being a Bruin is giving back to our surrounding community, and a way that BMES plays into this is by offering hands-on learning opportunities to middle schoolers and high schoolers and elementary schoolers from underserved communities, specifically Title I schools. And next slide. So we have 3 different branches where we operate community outreach from. Primarily is the RISE, or Reaching and Inspiring Students in Engineering program. So here we go to a class of about 40 middle school students and also 40 high school students, about 3 times a quarter, so about 9 times a year. And we lead them through hands-on circuitry workshops, and each one tries to build on the previous one. And so essentially, you're showing these kids who have never seen any type of circuitry hands-on. Personally, I never saw any hands-on circuitry until I got to college, but you're allowing them to like play with these Arduinos, these microcontrollers, these breadboards, and they're lighting up and using switches and using joysticks. And it's really cool to see how much they can gather in such a little period of time. And then in the Science Day series, we host 90 middle schoolers for interactive day of bioengineering. So essentially it's a field trip. So we take this whole grade from a particular school, bring them over to UCLA, lead them through different experiments that are catered to their educational level. So like if it's elementary school, then we'll do like strawberry DNA extraction. And if it's someone like middle schoolers, we'll do something more complex. And we also lead them to a tour around the campus. And lastly, we do a food drive, and it's usually during the holiday season. And over the past like 2 years, each year you usually raise around $300 and 100 items to the West Side Food Bank.
Okay, awesome. So another big component of BMES is our mentorship, which is personally one of my favorite parts. As you can see on the left, we had very large events across all 4 families when we were all in person. But in the middle and on the right, you can see, despite being apart from each other this year, we're still able to foster a great family community. And I hope this is something that also intrigues you guys, because it's not very often you can find such a group of people who are so willing to support each other. And it's something I personally value a lot. So delving more into detail about how our mentorship families look, we have 4 mentorship families named after all of the different DNA bases. when you come and join BMES, you fill out this mentor-mentee pairing based on what you're interested in accomplishing, either career aspirations or maybe what you want to get involved in at your time at UCLA. And we'll pair you with a mentor who has similar interests. So kind of like our alumni network, you get really tailored advice. So you can make the most out of your experience here. A lot of our mentorship events are fun, so they're a good break from the stress of classes. So we have Taco Tuesday nights, game nights, movie nights. We also set up intramural sports like my loan was a part of. And we also have a lot of mental health awareness events because we really believe that if your brain is healthy, then that's like setting you up for success, right? And we have a lot more events outside of these listed here as well. And you can look forward to 4 or more events every quarter for each family. So there's a lot of opportunity to meet other people in undergrad as well as people in other families. So it's really fun to be in a family.
And so the last thing is our social aspect, which is one of my favorite aspects personally. And Lynette talked about mentorship, which is like a great way for you to get to know people on a smaller scale. And these socials are club wide. So you have a bunch of people come out to about 4 events a year. So they either are like more formal events where you can dress up and take pictures with all your friends, or it's more laid back. We play a spike ball, it's a barbecue type setting. And these socials are like a great way to meet your friends. And you, as like Dr. Lee talked about earlier, it's like a very tight community in UCLA Bioengineering. And this really helps facilitate those friend groups. I know freshman year, I didn't know anyone. And I went to the first event or like holiday party and definitely got to know a lot of my friends that I have today. Next slide. So a little more into like what exactly the social events entail. Like we have our more like dinner bonding, little low key events that are like Korean barbecue, karaoke, street food, things of that sort. And then, as I said earlier, you have the ones that you can dress up for and you get free food. And it's a fun time. That's like holiday party, b-ball, and the banquet. And lastly, you have the more outdoorsy sports types. You have broom ball, which you may not know, but it's really fun. You go to like a hockey rink and you try to score goals and you like run around the ice rink, but it's pretty safe, don't worry. Beach days, hikes, things of that sort. So it's a really fun time and definitely is one of my favorite parts of BMES and being a UCLA bioengineer as a whole.
Awesome. So with that, that's the end of our presentation, and we want to thank you again for being here. Please let us know if you have any questions during the Q&A section at the end, or if you have any questions after today that come up to your head, feel free to reach out to us on these socials. And yeah, hope to see you become a baby Bruin next year. And feel free to reach out as always. Thank you.
Great, thanks a lot, BMES. That was really very informative. So now we're gonna play a game. And so we'll see how this goes, right? Because it's virtual. There's going to be a prize. So there'll be 2 winners. But unlike when we do this in person, you only get the prize if you matriculate to UCLA, right? So you win, come find me, and then I'll give you your shirt. Okay, so we're going to do it on Kahoot. I need your real name, so not like Bot1 or your mama or whatever you do on your phone games. Okay, I need your actual name. So I'm going to stop recording first. All right, recording is back on. Let me turn off the bad music from Kahoot. All right, we're good, we're good. So any questions? We have about 13 minutes before the alumni take over. So any questions?
Hi, my name is Pranati Kololi. I'm an incoming freshman from Orange County, and I have a question regarding the technical breadth that was going explained on. Is it possible that we can take like the regenerative medicine and like a pre-med track, or is it just you have to choose either or? Is there like an in-between for that?
Dr. Schmidt, do you want to field this one?
Yeah, I mean, the pre-med track is basically just intended for you to be able to fit all of your pre-med requirements and not have to exceed your 185 unit graduation requirement. So life science 2-3L or biostats, like if you had to take that on top of a normal load, then like maybe that would be a little bit too much. And so like it's totally possible for you to take to satisfy all of your pre-med requirements and take a different technical breath area. So that's not a problem at all.
Okay, thank you so much.
Yeah, and a lot of our students do that because a lot of them that are pre-med are also interested in that track. Other questions?
Hi, I'm Unique Jain. I'm an incoming freshman from San Diego.
Nice
And my
hat.
question is for Tamara. Were you the one who did who's doing electrical engineering, even though you studied bioengineering?
Yeah.
So how do you work in a different engineering field than your major of choice?
Yeah, so I think I chose bioengineering coming into UCLA because I was really interested in like going to, well, I was pre-med coming in, but then like first year I decided I wanted to go into medical devices. But your tech breath really prepares you like for all the theory behind, things electrical engineering related. But then BMES and other clubs really give you the ability to get that hands-on experience that you want to like get out of your college career. So like whether that be taking an E96 class, joining a design team through BMES. So that's how I did it. I got a lot of hands-on experience through that. And then during my interviews, I decided to apply to biomedical device companies as an electrical engineer. So I could like do two things at once really, and really emphasized my experience in the different clubs that I took and the different teams. And that's what they were really looking for. Like everyone really does have that foundation when it comes to like theory, but companies really want to see that you have that experience. And so like definitely use all of your resources that you can. So like join a research lab, so my research lab was in electrical engineering too. So like I had all the different backgrounds that I kind of needed and really emphasized all of that when I was interviewing.
Tamira, you work for OSCAN, right?
Yes.
Yeah, so Professor OSCAN, he's one of the professors at UCLA that actually has appointments in more than one department. So he's both an electrical engineering professor and a bioengineering professor. So that really helps a lot with sort of the crossover.
I guess Tamira, the fact that you know like physiology, but you also know circuits, etc. I mean, did that play a strong role?
Yeah, I think in my hiring manager like kind of gave me insight after my interview, and he told me that he likes to hire like bioengineers because they have all of the like background and how the body works, but then also look into bioengineers who have the electrical background because they like are able to combine two things at once. Whereas like electrical engineers sometimes who come in don't know much about the body, and so they have to spend their like internship learning about things, whereas like bioengineers come in with that background too. So like having both majors kind of in my pocket really helped me.
Great, thank you.
Mm-hmm.
Next question. Any questions?
I have one. Hi, I'm Lakshman from Northern California, and I'm a freshman coming into bioengineering too. And I was wondering, like, I've heard a lot of rumors at UCLA about graduating in 4 years and how that's sometimes hard because you can't get the classes you want. So I was wondering if that's actually true or if that's just a rumor.
Yeah, that has not been true, but I think Erky can give really more information. But from what I've seen, that's never been a problem.
Yeah, you shouldn't have problems graduating in 4 years. I think probably all the students here are graduating 4, and you've done things that are extra. Shika changed majors, still graduating in 4 years. So I usually look at it like this. If you don't graduate in 4 years, it's because you consciously chose to do something. Either you're doing a minor. Doing a minor is like another 6 or 7 classes. Sometimes that means you just have to stay another quarter. Sometimes people go abroad, and that might make you stay another quarter. But a lot of people go abroad and still graduate in 4 years. You fail classes. Sometimes you fail a class, you have to repeat it. That's going to make you stay longer. But in terms of getting classes, one of the things that UCLA always likes to say is you might not always get the class you want, but you'll always get the classes you need. And the way I interpret that is like, you might have to take the class at 8 a.m. every once in a while. Like you're not always going to have the perfect schedule. Or you might, sometimes they might offer 2 different sections of physics, and one professor is known to be easy and the other one is known to be hard. Sometimes you have to take the hard one, and people will delay taking a class because I don't want to take that hard professor. But then sometimes that has a domino effect that makes you stay longer. And the other thing, which I kind of think is like the dumbest thing you can do, is people who don't register for classes immediately when their enrollment pass opens. I see students who they're like, oh, I couldn't get into Life Science 7A. And I look, I'm like, their enrollment pass started on like November 1st, but they didn't even log in until like November 15th. And that point, like, we can't help you there. Like, that was just a huge mess up on your part. So I think generally speaking, if you're smart about the way you approach it, like, it shouldn't be a problem. Like, almost everybody, I think our average time to degree is like 4 years and a quarter, but like, that's not removing the people that are doing double majors and minors and people that change their major second year, stuff like that. So you should be fine.
There are also some transfer students that want to spend a little bit more time here because we get a lot of our student body that comes in as entering juniors, transferring from a community college. And so for them, if they wanted to have like an enhanced research experience, or if they wanted to get more of the UCLA experience, then they'll be here for the extra. So I think that that also skews a little bit of the averages.
Yeah.
Also, if it helps you feel better, like I know a lot of my friends have graduated a quarter early. So if you're not doing a minor and they still take extra classes, you can easily graduate a quarter early. And they did some summer classes too.
Yeah, especially like this current class, I think a lot of them finished in like 3 years and 2 quarters, maybe 1 in 3 years. So I don't know. I don't think it's an issue. Other questions?
Hi, my name is Audrey Sogata, and I'm from Chino Hills, California, which is in SoCal. But I'm looking to go into medical school, and I was just wondering how the bioengineering major prepares you for that, and also for a med school admission itself. Because
Yeah, Milo. Oh, go ahead. Sorry. Yeah.
I've heard mixed things about how your major doesn't matter, but some people say that like a bioengineering major is like really strong in admissions. So I'm just wondering more about that.
Yeah, I can touch upon that. Yeah, I did have those exact same concerns 4 years ago when I was in issues. So my 2 cents about it is that like maybe just from a pure GPA perspective, med schools may not look too much into your major, but it does make you a much better applicant as a whole, I feel. In a couple of ways, I'd say like your coursework you take at UCLA is going to well prepare you for any tests you need to take, MCAT or whatnot. And also like from a perspective is when you're in med school admissions committee member looking at applicants and you see a bunch of biology majors and you see someone who's bioengineering and they have experiences with engineering, right? Like they either worked in med tech or they did some research. That's pretty cool, right? To have that type of perspective when you go into med school. And med school is all about bringing diverse people onto their campus. So that's why I feel like if you have an engineering perspective, you give you an advantage as long as like you're able to complete your courses in a timely fashion. But I think that shouldn't be a problem. So I definitely think it can be challenging at times, the coursework, but I think it's definitely well worth it. And like people who end up pursuing med school after graduation go on to like great places. So
yeah, they do very well. They do extremely well in placing. And I think once they get there, they're extremely successful too, because the program here is rigorous. There's a question in the chat from Panati. Are there certain minors that have the most overlap with like BE, the BE major? So one is you can't do a minor in engineering. So those are gone.
Yeah, you can. Yeah,
you can do a minor?
Yeah.
You can't double major.
Correct.
You can't double. Okay. So what would be like a minor that would be the closest with BE courses?
Well, I guess the thing about the overlap is it's good to have overlap, but they limit the amount of overlap you're allowed to have because they want you to earn the minor. So the rule at UCLA is that 20 units, and you can think of 20 units as basically 5 classes. 20 units of the minor have to exclusively be applying towards the minor and nothing else. Because the thing is, like, if you minored in like math and you did the tech breadth in math, you can do the minor with like 1 extra class. And I think what UCLA thinks is like, you're not really earning a minor by taking 1 class. So you do kind of have to find things that don't overlap too much. But having said that, math is a common one. But then, those people just won't do the tech breadth in math, so they have the 5 extra math classes. There are some other ones that overlap with bio a little bit. Let's see, I think there's some like neuroscience type ones. And actually, you know what? Another popular minor that a lot of bioengineers do is biomedical research. And I think the big overlap with that one is they require you to do research. And like Professor Lee was saying, 90% of the bioengineering undergrads do at least a year of research anyway. So that's actually a good one. And a lot of the classes that you have to do for that minor aren't, like, I think one of them will satisfy a GE anyway. So that's another overlap. And then I think the other ones don't overlap, but they tend to be like seminar type courses. So they're not, you know, terrible. But a lot of people that do minors, they do it something completely the other direction. Like they'll minor in French or something like that. So I think, you know, minors, you can look at it as a way to enhance your interest, but you can also look at it as a way to kind of do something that maybe you had an interest in high school, but it doesn't fit in with your major. Like, you know, yeah, if you love languages, or if you love, you know, like psychology, or you know, because you took AP Psych, but then there's no psych in the bioengineering department. So, but minors are cool. Like I said, you know, it's going to be a minimum 5 extra classes, maybe as many as like 7 or 8, but you can fit it in, especially if you come in with like AP credits and maybe you took some classes at the community college. Like you might be like 3 or 4 classes ahead anyway, and then so kind of it'll even out, and you know, you can do it in the 4 years, you know, without having to do anything heroic.
Great, thanks. Maybe one last question before we hand it over to the alumni. Any last question, at least for us for now. But we're all in the breakout session, so if you have questions, please come. Yeah, people are going to the breakout session, so it'd be suck if no one came. All right, so let's go to the alumni. I will introduce them, and once I say your name, they can start. They have about 2 to 3 minutes of talking about their experiences. But we'll start with Quincy Chin. Hey, good to see you, man. Long time. Class of 2013, I think?
Yeah, that's right. It's been quite a while. Yeah, my name is Quincy. I currently work at Google, or Alphabet, I guess the technical name for it. It's a small company in Palo Alto. I hope most of you might have heard about it. I work there in the APAS team, AT&C. So that's ads privacy and control, as well as ads transparency and control. And what I do is basically I make sure that when Google serves you ads, we make sure that we take privacy into account. And when third party tries to serve you ads, we also make sure that privacy is taken into account and your information isn't sold to people or disseminated in ways that you don't want it to be. As for how bioengineering helped me get to my position, I would say that the most valuable thing that I've gained from UCLA would be the networking that you can get from being in the BE program at UCLA, as well as having one-on-ones with your professors. I found that to be, at least for me personally, extremely valuable. You know, 2 of the things that from 2 professors that I think helped me the most were one from Dr. Schmidt, who was my PI, shout out to Schmidt Lab. Throughput. That's always going to help you when you think about, you know, getting things done or trying to produce value to achieve results. You know, throughput is always going to be important. And actually, one of the things from Dr. Kamei that really helped me out was understanding that if you want something, you should reach out and take it. Things aren't going to just be handed to you on a platter. So yeah.
Thanks, Quincy. I'm glad you're listening. No, I'm just kidding. Thanks a lot, and thanks for coming today. All right, next up we have Philip Cox, class of 2017.
Hi guys, my name is Philip. As Dr. Kamei said, I graduated in 2017. I work at Moderna, and for the past year, my team has developed the process to make the COVID vaccine, and we open up various sites around the US and Europe as well. And then more recently have been working on seasonal flu vaccines and also the COVID variant. So developing how to make our mRNA product. And how the program has helped me, I guess I want to echo what was said. The network is really valuable, not only with your classmates, but I think a lot of the professors too. It opens you up to a lot of different backgrounds and experiences that really broaden your perspective. And also, I mean, going to UCLA, the education is obviously a given. It's very good. But there's just like lots of opportunities available for you to take, not only within the engineering school, but also outside. And again, it really helps you become a well-rounded engineer when you graduate, getting experiences in all types of areas.
Great, thank you. Next, we have Eva Chen, class of 2018.
Hi, everyone. My name is Eva. I graduated from UCLA Bioengineering in 2018 and also got my master's in electrical and computer engineering from UCLA in 2019. I just loved UCLA that much. I currently work as a product manager at Microsoft, working on Microsoft Edge, so that's the browser, and I help keep users' identities safe while they browse the web. So not very related to bioengineering, but I was super interested in PMing and kind of that project and product leadership. While I was at UCLA, I worked at the OzCan Research Lab, so that was more on the electrical engineering side. And I also interned at Apple on the Apple Watch, as well as Medtronic for the algorithms team for the continuous glucose monitor. Those were both in the engineering space, and I kind of shifted over to product management after graduation. And what I loved the most about UCLA that really helped me out was that I kind of met my best friends that they're my best friends for life at UCLA Bioengineering. We all kind of just met through BMES and BE10 and through Dr. Kamei's classes and things like that. And they're my best friends. But also UCLA has a lot of really great recruiting events. All of the jobs that I've ever had were through some kind of UCLA recruiting, whether it be through an email or through a networking session with BMES or with Microsoft. It was with the Society of Women Engineers industry dinner. And so the different recruiting events at UCLA are really awesome. Companies really want to hire from UCLA. They really want to hire great talent. And so that's kind of something that was super helpful when I was at UCLA.
Fantastic, thanks, Eva. And I think your friends are called amino acids, if I remember correctly.
Yes, our friend group is called the amino acids, and we all have an amino acid name, and that helped us memorize all of the amino acids when we had to learn them.
Great. All right, next we have Miriam Mimi Carson, class of 2020.
Hi, everyone. My name is Miriam. I also go by Mimi. I graduated in 2020. I was also a member of Dr. Kamei's lab, so shout out to Kamei Lab. But I also minored in Spanish. So if anybody's interested in learning more about minoring in something that doesn't really have anything to do with engineering and how to fit that into your schedule, I'm happy to answer any questions about that. Now I'm up at UCSF getting a master's in global health sciences, so pretty different from bioengineering. I wanted to sort of do a transition into public health, and so that's kind of the route that I took. And I would definitely say that UCLA bioengineering prepared me for that because I'm still doing research, and I think that Kamei Lab really prepared me for how to think critically and thoughtfully about what your experiments you want to do, what results are you trying to get, and just collaborating and working with different people on a team. I think that's really, really critical, especially in the future. No matter what, you're going to be on a group project. There's no way to avoid it. So you have to learn how to work well with others. And then the other thing I would say is that the faculty here are very invested in your success. And so they're there to help you, and they welcome you to reach out to them for anything that you might need because they want you to accomplish the goals that you want to set for yourself. And so definitely take advantage of that because that's what they're there for and they want to help you.
Great, thanks, Mimi. Maybe you could say a little bit, I know you're at the forefront of fighting COVID. Maybe you could say a little bit.
Oh, yeah.
We got Philip making the vaccine, and then we have Mimi also helping.
Yeah, I've been a volunteer EMT at a clinic up here in San Francisco, and I've been testing people back when we were in several different surges, and then now I've been administering the Moderna vaccine. So thank you, Philip.
That's great. All right, so last but not least, Layla Rad, also class of 2020.
Hi, everyone. I'm Layla, and currently I'm a first-year PhD student at the University of Michigan, and I'm kind of focusing on using allergen-loaded nanoparticles for food allergy. And I guess I really want to second what Dr. Meyer said about having an unfair advantage going into grad school coming out of my undergrad degree from BioE here. And it's kind of like I've talked to some of my classmates and they kind of feel like they're struggling. And I'm like, that's unrelatable content. Like I kind of really knew what I was getting into coming out of undergrad, going into grad school. And I don't think everyone can say that. I was pretty confident, like integrating into a research environment in undergrad and working with different graduate students and postdocs at UCLA. And so that really gives you like a really clear and realistic perspective of how difficult research can be. And so when you want to transition into industry or grad school, you kind of have a very like realistic expectations for failure, but also like it gives you persistence that gets you that success you need. And a bit of some other things about UCLA that I think people haven't emphasized, like I agree with everything everyone has said, but like the UCLA campus, the way it's set up is like a big advantage because something at Michigan here is like it's a really big campus and it's kind of difficult to get from place to place. But like your labs are right next to your classes, so you can kind of like go to lab and go to class with such a smooth transition that really makes you like feel a part of your lab. And I've noticed undergrads at Michigan don't have that exactly because the labs are kind of separated from their like the physical location of their classes. And so I think that's just like something I didn't hear before I got to Michigan that I think UCLA has a big advantage. Plus the medical school is just right there. And there's a lot of collaborations with BioE and the medical school. And I think that's like really promoted because of the location. So that's just one really cool thing about UCLA. And yeah. Oh wait, one last thing. One thing that Erky told me like during this when I was coming in is like about the quarter system. Like I don't know if you guys are a little bit worried about that, but like I was really worried about going into a quarter system and studying engineering coming from like not an engineering background. And Erky just told me like you're just going to get good at studying. And like, I didn't believe him, like even into my first year, I just was like, I don't know if I'm going to be like good at like studying for these hard engineering classes. But then by my third year, it was kind of like I was barely studying, getting like good grades, understanding the courses. And like, I was like, Erky was right. Like he was totally right. Like I definitely know how to study efficiently, go to lab, have fun with friends and like be a part of BMES. And so I think being in a quarter system and now transitioning to grad school, like, or even industry, you just know how to like be really efficient with your time. And I think that's also a really big advantage that maybe you'll feel like a little bit of pressure at first, but like believe in yourself and it'll like work out for you guys. Okay, yeah, that's all I want to say.
Awesome. Thank you, Layla. So those are our 5 alumni took time out of their busy schedules to be with us today. Any questions for them? I'll start. Hey, Philip, I got a question for you. So you went to Moderna, but that was before COVID, right? And so what made you decide on Moderna? This is just I've been curious, and since you're here, I'm going to ask you.
Yeah, sure. So in my undergrad, I interned at 2 very large biotech companies, Genentech and Amgen. And when I was there, I realized that, especially with big companies, you're really just like a cog in the wheel. You don't get to wear a lot of different hats. You don't get to be a part of you're not very close to the innovation from my perspective. So I was looking for something very small. And something very exciting, new technology. And so it just so happened like Moderna was hiring after I graduated. And so I decided to move to Boston. The weather was not a drawing factor, but that's okay. And here I am.
Cool. Thank you. Other questions for the alumni? I have another one. Hey, Mimi, you did a minor in Spanish. So, like, how do they look at it when someone's coming from engineering and then you want to do a minor in, something that's far from engineering? Like, are the departments very welcoming? How does that work?
Yeah, so there is like a little bit of administrative stuff that you have to do to apply for a minor in the first place. You have to, I think I had to write like a short paragraph about why I wanted to do that specific minor. And like my personal background was I went to a bilingual middle school. I did Spanish through high school. I just wanted to continue developing that skill in college. So that wasn't a very difficult paragraph to write, but you have to show that you want it. And then you have to also submit a schedule for approval to show that you can fit that minor into your major without extending the amount of time that you'll be at UCLA, so that you can like reasonably accomplish all of the curriculum within 4 years. And so I did that, submitted my course schedule, and that was approved and everything. I did end up taking a couple summer classes, but that ended up working well because I was doing research anyway. And so I could take classes while also doing research. But the department was super welcoming. It was I was definitely the only engineer in all of my Spanish classes, but people were like interested in what I did, and I would talk with them about that, but I never felt like ostracized or anything like that. Everybody was super welcoming, and I have nothing but great things to say about the Spanish department. So I would highly recommend doing that minor. I learned a lot. I think it supplemented my bioengineering background really well in terms of just like learning about different cultures, and like, their needs are different from ours. So if you're like trying to design an engineering solution, like Dr. Kamei's lab focuses on diagnostics, and specifically diagnostics in resource poor settings. So like, you can't develop this really fancy lab solution to something if the place you're trying to implement it doesn't even have a lab. So it was just like interesting to have this cultural supplementation to my bio.
And then I guess you're using Spanish as you're vaccinating people and testing people. So I think that worked out really well.
I am. Mm-hmm.
All right. There's some questions in the chat. So I'm going to go first to Christians. What are some tips to really get a focus on medical devices while in bioengineering? And also, are there any research opportunities for someone wanting to focus on medical devices? So, any of the alumni, or Eva could kind of speak to that, right?
Yeah, I could kind of speak to that. So I think it really matters kind of which labs that you decide to do research in when you're in undergrad. Since when you're applying to kind of maybe grad school, or when you're applying to industry, they're really going to look at your previous experiences. And most people, if you're in college, you don't have other industry experiences. So they're really going to look at your research lab experiences. So my recommendation would be to really look at the research labs that focus on medical devices. There's a few within the bioengineering department, as well as within different engineering as well as medical departments on campus. So that's kind of what I did. I started in the OSCAN lab, which focused on the microscope on a phone. So that was kind of a medical device. And then I kind of from there went into the Apple Watch, which is also kind of a medical device. And then from there, I decided that I wanted to really focus on signal processing within medical devices. So that's why I decided to do the master's in electrical engineering, just because they had a signal processing track within the major. And then from there, I was kind of able to work on algorithms within the continuous glucose monitor. So from medical devices, kind of like start with a research lab that's in the general field. And then from there, you can really narrow down like specifically what part of medical devices you want to work on, and then kind of just like finagle your way there through different experiences and coursework.
Great, thanks, Eva. Next question is for Quincy and Eva. How did you transition into a job that wasn't bioengineering focused?
Okay, I can go first. So so this job is very much tech focused. I work with folks that did CS for their majors. So I don't have much background into CS, but for the role of a product manager, they don't really care if you have a CS background. Like they would prefer that you do have a engineering background so that you at least understand like the technical concepts. I think that having a master's in electrical engineering helped a lot in that I could kind of prove that like I knew some of the CS background. But when I was kind of like interviewing for product management roles, they really care more about like the way you think. If you're able to be a logical thinker and you're able to wrap your head around these really complex ideas, and then how you would go about solving these problems. So when I am at work, like when I first started, I was like, hey guys, like I'm from a medical tech background. Like I don't really know anything about the browser or about like CS. So I'm really going to have to lean on you guys to kind of help me out. And the way that kind of product management and engineering is set up at Microsoft, they very much lean on each other. So the engineers lean on the PMs for kind of that organizing, that prioritization, kind of the high level goals. And PM really relies on engineering to kind of, you know, get the work done. So the way that the companies are set up, usually that if you're in the product management space, you can get away with not having a deep CS background, as long as you're able to kind of work with, you know, other engineers, understand the problems, kind of, and just kind of speak the same language as them. So that's kind of how I transition, and I'm feeling really at home now. So I think a lot of the skills that you learn in bioengineering, because it's such a hard field, you take a lot of those complex problem solving and logic skills over to whatever you end up doing with your career.
Cool. Quincy, anything to add?
Yeah, for me, working in software, you know, obviously it's, you know, a little technically different from working in a wet lab and stuff like that, but we do have well, I don't know if you guys still do, but when I was at UCLA, there is a requirement to take a programming course for the undergraduate degree. And that was a course in C++. It was a pretty okay introduction to programming. But you know, it's not going to compare to, you know, having an entire degree in CS. You know? But that being said, when you look at companies at like Google, Facebook, Apple, or Netflix, you know, they don't really care whether or not you have a CS degree. All they care about is whether or not you can do the job. And the interview process for these large FANG companies are usually pretty well documented. So you just have to go and you know, kind of reach out and find resources online to study for them, and they won't care as long as you can pass the interview, pass the bar. You know, they will hire you. So that wasn't too much of an issue coming from bioengineering.
Cool, thank you. Next question, maybe for Philip. How competitive is the bioengineering field in industry compared to other majors in engineering?
Yeah, I mean, it all depends. It like comes down to what you want to do. What's great about the bioengineering major is, as you can tell from all the alumni, is it's really flexible. So a lot of people are able to go into a lot of different fields. And so if you're not sure kind of what you want to do, that's a big advantage. But I think because our like coursework is so broad, we get to experience a lot of different fields and get exposure to a lot of different things. So it just really depends kind of what you wanted to do. And yeah, I think because UCLA is so reputable and bioengineering, the program is so great, I think whatever you do want to do, I think you can definitely get there.
Great. We have, I think, 7 or 8 more questions in 8 minutes. So we're going to probably go through a minute each. So for the alumni who said networking was one of the best parts of the B program, was that because of BMES or something else, or a combination?
It was because of both, actually, believe it or not. So the reason I would say that is because right out of UCLA, I actually went to work almost immediately after graduation at a place called Baxter, which became Baxalta and now is known as Takeda. I think you guys might have seen that. That was through BMES, where, you know, we had the BMES leadership at that time. They took us to a group trip to Baxter, and that's how we were, like, it was super easy to get a job from there. Like, I applied to one place and just got in, so that was great. When I wanted to transition to CS, I got back in touch with one of the I don't know if you guys remember, but the guy who did IT at BMES, for BMES, Terry, he actually introduced me to CS and helped me get a job at UCLA's registrar's office, I believe. And that's where I actually started my CS career. And as for where I am now, believe it or not, it was another BE student who introduced me to someone who worked at Google. And he actually gave me a great referral that helped me land the job here. So like networking has been a pretty solid foundation for me getting into kind of everywhere I've been so far.
Great. Next question. How challenging is it to graduate with a double major? Is it feasible, or do most focus on a major and a minor? Maybe Erky?
I guess it depends on what that double major is. If you're doing a double major, there's going to be a lot of extra coursework. I would say that most people that do a double major are going to stay at least a couple of extra quarters. I've seen people do it in 4 years. We had a bioengineering major who graduated maybe like 5 or so years ago. First name was James. I forget his last name, but he did a bio-E and econ, but he came in with some credits and then he always went to summer school. But he was able to do, and then he ended up working in civil engineering after graduation somehow. But so you can do it, but it typically takes some summer school.
Great. Go ahead. Yes.
Just like really quick to add on to that, like my major and minor had no overlap. And even when I was able to count like one Spanish class as a GE, I still had to take several quarters worth of summer courses to fit everything together.
Awesome. Looking back, is there something you wish you had done differently during your years at UCLA? Or what is something that worked really great? Any suggestions for the alumni?
I have something to say. I wished I got involved with BMES a lot sooner, because everyone in BMES is your peers and also people who are older than you, and they have the resources you need. And the sooner you get involved with BMES, the quicker you'll realize how easy it is to succeed in the major, because everyone above you is doing it and they're going to give you the information you need to do that. And just go to the social events. Even if you don't want to go, just go and make friends quicker.
There's free food too at social events usually for BMES.
Well, let me chime in. I'm an alum too, not of bioengineering, but I went to UCLA. My biggest regret, I never went to Songfest. And I kind of feel bad about it. Songfest is one of UCLA's big events every year, and it's really, really cool. You're just blown away by the talent that your fellow Bruins have. And I never went when I was an undergrad, and I regret it.
Any other alum that wants to say something they regret or they liked? All right, everyone's at peace. That's good. I got a private chat, so I just want to bring this out. Is it valuable to do an MBA after an undergraduate in bioengineering? Actually, every year of graduates probably has 2 or 3 that end up doing an MBA. So they do a great job. Usually they work though. They'll finish and they'll work and then they'll go get an MBA. Some go directly to get a JD. But they end up in these companies that are biotech or biomed. So that has been good. I think the one thing you got to figure out though is, do you want to stay technical or do you want to get into management, right? Because once you go to MBA, then you're not really going to do the technical part of things. And some of us really love that part, and some of us don't. And I think that's something you'll figure out. A question for everybody do you have any advice for undeclared engineering students?
I would just go ahead and take as many of get the lower divs out of the way, because no matter what, regardless of your major, you're all going to be taking math, you're all going to be taking physics, you're all going to be taking gen chem. So ask around with your peers, see what majors they're in, see what other classes that are specific to the major that you're taking, so you can get in a little bit more perspective. But if you want to stick with engineering, my suggestion would be no matter what major you pick, the lower divs are almost identical. So I would start with those.
My recommendation to undeclared engineering students is to take some time and spend some time thinking about what you want to do in the future. To be completely honest, like, do you want to go after your dreams? Do you want to focus on getting a job that can pay the bills, right? Like, I know a lot of people come to UCLA to chase their dreams, but some people go to college to get a job that pays well, right? And then, you know, do research on that. You know, what do I have to do to achieve that goal? You know, what major do I need to get to where I want to be? You know, what job do I want and what major is best for that job, right?
Another question here, maybe the last one. Any of the students or alumni, were you on an FRC team by any chance? Did that help you in school at all? What is FRC? I feel my daughter would probably call me a noob or something, but what is FRC? Oh, robotics. Maybe not. No one's like jumping out to unmute.
Most of the students that do robotics are in mechanical engineering. Like those things are not restricted to certain majors, but that kind of tends to be where they are is mechanical.
I can kind of chime in just to talk about the background. I came from, like, usually in high school, my high school did not offer any sort of technical experience or anything beforehand. So I didn't take any AP computer science or really anything in high school. So all of my technical experience was gained through either UCLA BMES with the technical project teams or through other clubs and organizations that kind of gave that experience. So it really evens the playing field in college. So you don't necessarily need any technical experience beforehand.
All right. On this, I'm going to close this session. Definitely go to the School of Engineering site to see your last name and which Zoom breakout session to go to. You know, we have about 15 undergrad helpers, 7 faculty, 5 alumni, undergrad counselor, split up between these sessions. So really appreciate it if you just appeared, said hi, asked one question or something. Thanks again. I'm going to close this up and take care. Stay safe.